Let's talk about how you can develop a product that you can manufacture and sell. My name is Jeremy, and my team and I at Emergent Design Labs help companies design and develop and manufacture products that they sell to their customers. I'm going to show you the method that we use to help all sorts of different companies design and develop their products. So the first step of the product development process is usually problem definition. And that's because the most compelling value proposition of a product is that the product solves a real problem for its users. The most effective way of investigating the problem in the problem domain is to actually speak to the people who would be your customers who are experiencing this problem. And we call this market research. When you're doing this market research, you should search for pain or frustration or annoyance with the current solutions or the current way that these people manage this problem. Another thing to gauge is how important the issue or the problem is to the user. Anytime that you find a conjunction of those two things, high frustration and pain and then high importance, that's a good indicator that you've got a good opportunity for a product. The biggest mistake that I see in this phase is that you're researching the problem domain, and yet the people who are doing this already have a solution in mind. The problem is that you're presupposing and obviating the rest of this process that we're about to step through. Like a detective has to set aside their initial conclusions and follow the evidence where it leads them, you too have to set aside your initial conception of this product and go through the process from beginning to end in order for it to work as well as it can. I do want to touch on instances where this problem definition framework kind of breaks down. Because like I said earlier, the most compelling value proposition for a product is that it solves a problem, but that's not exactly the case with every product. You know, you think about toys or luxury goods. Trying to ask very probing and specific questions about what elements of their problem are dissatisfying to these users, in these cases might seem a little arbitrary. In that case, what I recommend is finding an existing product in your market and identifying the problems that the user has with that product. Now, the goal of this problem definition process is to develop a set of requirements for your product. Requirements are the criteria that the product needs to meet in order to be useful to your customer. The requirements should also cover all of the things that you need the product to be in order for it to be feasible for your business. So I like to write requirements as a list of I need statements from the point of view of the user. Our goal is for the requirements list to be exhaustive and comprehensive. We don't want to be adding new requirements later, but be careful not to include things that aren't truly requirements, because the more requirements you have, the more difficult your design process will be later on. And again, the warning that I gave you in the problem definition phase still applies here. Try not to presuppose the solution or the product while you're writing your requirements. These should come strictly from the market research and the problem definition work that you've done before. So sometimes that means being as generic as possible with the description of your requirements. Instead of describing a specific feature like a knob or a latch, describe the function instead and the value that it gives to the user. Okay, now that you've finished defining your requirements, you're ready to start the actual design process. But before we talk about that, I want to introduce you to a framework that we use at Emergent to plan the design process. We call it the 3 dimensions of the product design. The 3 dimensions are appeal, performance, and manufacturability. All 3 of these things are equally important in the product's design. Appeal is basically what sells the product. It's how useful is it to the user. I do want you, when you think about appeal, to also think about the way that the product looks. Does it look like something that the user is going to want in their home or in their workspace? The next dimension is performance, and this is a quality of how well do the parts fit together and work and do what they're intended to do. When you think about performance, you should also think about unintended consequences. Will the product do something that you don't want it to do or you're not expecting it to do? How is it going to react to the environment that it's used in? The last dimension is manufacturability. It's a quality of how easy is it for your product's design to be manufactured using a traditional and scalable and cost-effective method. Those are the three dimensions, and your goal in the design process is to maximize all three of those dimensions. If you maximize the dimensions and meet your requirements, then you're likely to have a great product. Okay, so let's talk about the actual design process. And like I said, this varies from product to product. But the first step in the design process is usually some kind of concept design phase. This is where you get to bring those ideas in that you've been holding back this whole time. But I want you to take it a step further. I want you to think of as many different ideas as you can. The more the better, get creative, think out of the box. But your goal is for all of these ideas to approach the requirements that you've already defined, each in a different way. One important thing to know about concept design is that it can be sort of intentionally lacking in detail. And the reason is that all of the details take thought, and you don't want to necessarily invest too much thought and valuable time into these concepts because we're going to down select later down to a single concept. For example, you may not know the exact size of the fasteners that are used in your concept design or the exact dimension of some feature, but that's okay. Instead, I want you to think about those three dimensions that we talked about earlier: appeal, performance, and manufacturability. Now, once you have a good selection of concepts, the next step is to eliminate them, to down select to a single one. And the way that you do this is by judging the concepts against the requirements. Think about which concepts meet the requirements the best and try to order them. Now, what you might find in this down selection process is that each of the concepts have their pros and cons. In this case, you can try to take elements from one concept and take elements from another concept and form new concepts from there. This is why we say the concept design process is iterative. It's very natural and very common for the process to go around in a circle of generating new concepts and then down selecting from those concepts and then generating new concepts again and down selecting. And you keep on doing that until you have a concept that meets your requirements really well, and you can't think of a better one. So once you get that one concept that you're satisfied with, now it's time to move to the next phase, and this is the technical design phase. This is where we really get into the engineering of the product. And this is the phase that really looks different depending on what the product is like. You know, if you have a mechanical product, then you're going to have a lot of mechanical engineering involved. If you've got an electrical or an electronic product, then chances are you're going to have a lot of electrical engineering involved. Now, all of these different things require their different tools, and I don't want to get into too much of that right now, but one of the most important tools in this phase is usually 3D CAD modeling. CAD stands for computer-aided design, and it's what engineers use to model your product in a 3D environment on their computer. CAD allows engineers to define and store all of the very fine, intricate details of your product and then export that into all sorts of different file types for manufacturing and prototyping. Speaking of prototyping, that's another important thing that happens in this phase. Now, I want to talk about the purpose of prototyping, which is to validate the design and specifically the performance. One technology that's really useful in prototyping is 3D printing, but it does have its limits. So work with your engineers on how you can prototype and validate through prototyping. The goal of the technical design phase is to complete what we call a production package. It's a set of files that a factory can use as a reference to manufacture the product, and it describes all the details of the product. Now, the production package is going to look really different depending on what the product is. For example, for mechanical products with mechanical parts, you'll have these mechanical prints and drawings and 3D CAD files. For electronics, if there's printed circuit boards, you'll have what's called Gerber files. If there's soft good components, then you'll have what's called a tech pack, which identifies all the materials and the assembly process with all of the sews and stitches. And then you'll usually have what's called a bill of materials, or a BOM. And the BOM is simply a list of all the components and their quantities and maybe some other detail like their materials and their sources. Once you finish your production package, you've finished designing the product and you're ready for the last step, which is production sourcing. The lowest barrier entry way to source a product is to approach a contract manufacturer or a sourcing agent with your design files, your production package, and have them give you a quote back. And that quote is going to tell you a lot of different things. It's going to tell you what their per unit cost is on the product. It's going to tell you what their minimum order quantity is. It'll also tell you what the lead time is and if there's any fixed costs like tooling that are associated with manufacturing your product. So best practice is to reach out to several different contract manufacturers and sourcing agents and get a bunch of different quotes. You will need to be careful to find manufacturers with appropriate capabilities for your product. So work with your design team and your engineers on that. But once you've gotten those quotes and you're happy with some of them, this is a good time to ask the factory for a production sample. This is like a one-off for a small quantity batch that they'll produce of your product just to show what they're capable of. Now, there's a big difference between a production sample and a prototype. Prototypes are what we did during the technical design phase in order to validate the design and specifically the performance. And we said that we're probably using different technologies than we would in manufacturing. The production sample is done by the factory, and they're going to use the same technologies and try to get it as close as possible as it would be to the final product. And when you have the production sample, you're not only validating the design, but also the quality that the factory provides. It's a good idea to get production samples from more than one factory so you can compare them not only with their quotes, but also with their production samples and their quality of work. Once you have a production sample and a quote that you're happy with, the product development process is effectively complete. You've gone all the way from identifying a problem through a comprehensive design process to now you have a product that you can order from a factory in quantity and you can receive it and you can warehouse it and you can sell it to your customers. Obviously, there's a lot of detail that we skipped over here and the process can vary depending on products. So that's why it's a good idea to work with a full service product development firm. And if you have any questions about how you can make this process work for you and your business, click the link in the description of this video to get in touch with my team and we'll find a way to help you. Thank you so much for watching this video and best of luck developing your new product.